The following information applies to problems 21 and 22. Water flows through a pipe with a radius of 5 cm at a velocity of 10 cm per second before entering a narrower section of pipe with a radius of 2.5 cm. Problem 21. What is the difference in the speed of water between the two pipes? Problem 22. To measure this difference, two graduated cylinders are connected to the top of the pipe, one in the broad section and the other in the narrowed section. Water then flows up each pipe and the height the water reaches is measured. Estimate the difference in height between the two cylinders. Problem 23. The student conducted an experiment to determine the spring constant of a spring using a ruler and two different weighing scales. The measured elongation of the spring was 1.5 centimeters, and the smallest division on the ruler was 1 millimeter. The mass of the attached weight was measured using two different scales in the school laboratory, yielding values of 198 gram and 210 gram. The student also found that the local acceleration, due to gravity in her city is given as 9.806 plus or minus 0.001 meters per second square. Calculate the percent error in measuring the spring constant. Problem 24. A massive bead is attached to the end of a massless rigid rod of length L. The other end of the rod is attached to an ideal pivot, which allows it to rotate frictionlessly in any direction. The rod is initially at angle theta to the horizontal, and there is no gravitational force. Next, the bead receives an impulse directly into the page, giving it a speed v. How long does it take for the bead to return to its original position? Problem 25. A puck of mass m can slide on a frictionless inclined plane, prism. The prism has a much greater mass, compared to the puck and is itself sliding without friction on a horizontal surface. The velocity of the prism is v equals square root from 2gh, where g is the acceleration due to gravity and h is the height from which the puck starts sliding on the prism. The transition from the prism to the horizontal surface is smooth. The puck starts from rest relative to the prism. Find the final velocity of the puck once it begins sliding on the horizontal surface.